Now, in this video, we are going to take up one more problem on projections of laminas. How to analyze this problem and solve by using the sketchbook. The problem reads as a pentagonal lamina having edges 25 mm is placed on one of its corners on HP, such that the surface makes an angle of 30 degree with HP and perpendicular bisector of the edge passing through the corner on which the lamina is appears to be inclined at 30 degrees to BP. Draw the top and front views of the lamina. So in the initial position, how I should be able to consider whether it should be considered from the HP or it should be from the VP. So since he says it is resting on one of its corners on HP, obviously I have to start the problem from HP. And also he has given the surface makes an angle of 30 degree with HP. Since the surface inclination is given with respect to HP, so I have to make the lamina parallel to HP. If I want to make the lamina parallel to HP, obviously it should be started from the top view, because the surface is parallel to HP means, and it should be perpendicular to VP. So in the front view you will going to get a line, whereas in the top view you will going to get the true shape, that is the true length. So we have to start the problem from the top view. So first we are going to take up the initial position of the pentagonal lamina. So whether it is resting on HP or whether it is resting on corner, in a pentagon always you have to make the edge perpendicular to VP. So this is the edge which is perpendicular to VP. And you construct a lamina, you have to place the lamina in the horizontal plane such that one of the edges is perpendicular to VP. So when you look from the top view, you can see all the sides are in true length. Why all the sides are in true length? Because all the sides are parallel to HP. Therefore, in HP, you will going to get the true length. Where to see the line which is parallel to HP? I have to look from the front view. When you look from the front view, you can see that there is a line in the vertical plane. So here, what does it mean? If you look from the front view, AB is nearer to the observer, so A dash B dash is visible. BC is near to the observer, so B dash C dash is visible. C and D dash is away, C is visible and D dash is away from the observer, because D dash is coinciding with the point B. Therefore, D dash becomes invisible. Similarly, E dash. And also, then we have the perpendicular bisector. What is the perpendicular bisector? Pentagon, you will going to get 5. How? Because you have 5 points. From each of these corners, you will going to get a perpendicular bisector by drawing a line between point A to the opposite of the midpoint of CD. Similarly, from B, opposite to the midpoint of DE. From C, opposite to the midpoint of AE. From D, opposite to the midpoint of AB, and from E, opposite to the midpoint of BC. So we have 5 perpendicular bisector, out of which one has to be considered? The perpendicular bisector which is parallel to VP. Which is the perpendicular bisector which is parallel to VP? That is CM. So CM is the perpendicular bisector which is parallel to VP, and all other perpendicular bisector will be inclined to VP. Therefore, you will not be able to get the true length. So since you are able to get the true length only in the perpendicular bisector of CM, therefore CM is considered to be one of the perpendicular bisector. That is the reason why we have C dash and M dash is in bracket. Why M dash is in bracket? If you look from the front view, A is hiding the point M when you look from the front view. Therefore, M dash becomes invisible. So this is how you will be able to analyze the pentagonal lamina in 3 dimensions in the first position. So how to write this? By using the orthographic view. First we are going to draw the XY line and mark VP and HP. And in HP, first you measure a distance of 25 mm and draw a vertical line. And you mark that point as A and E. By using the protractor with A as center with respect to EE, you measure an included angle of 108 degree and then draw a inclined line here. Similarly, with V as center with respect to EA, you measure an angle of 108 degree in included angle, then you draw an inclined line. Then by using the compass, you measure the distance of 25 with A as center, cut on this inclined line. Similarly, with E as center, cut it on this inclined line, and you mark those points as B and D. With B as center, taking the radius of 25, you draw an arc. Similarly, with D as center, taking a radius of 25, cut on the previously drawn arc. So you will going to get a point here. You mark that point as small c. Then join A to B, B to C, C to D, D to E, and E to A with a dark line. From C, you draw a horizontal line which will be automatically the midpoint of EE, and you mark that point as F. And then from AEM, you draw a vertical projector to the XY line. Similarly, from B and D, you draw a vertical projector to the XY line. And similarly, with CS, from C, you draw a vertical projector to the XY line. As you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible. D and E is away from the observer, and it is coinciding with the point B and A respectively. Therefore, you mark that as D dash in bracket and A dash is in bracket. And also, when you look from the front view, the CM is the perpendicular bisector wherein it will be parallel to VP. Therefore, you are getting the true length here. So, M dash will be in bracket because the point A is hiding the point M. Therefore, M dash will be in bracket. And then join A dash to C dash with a dotted line. Similarly, A to B, B to C, C to D, D to E, E to A with a dotted line, and you mark this point as small m. Then show the dimension of 25. Once you do that, now we will go to the second position wherein he says the corner is resting on HP. So here what is happening in the first position, all the sides are resting on HP. So here this side is this end is a side and this end is a corner. How do I know that? When you look from the top view, AE is the line which is perpendicular to VP and parallel to HP. Therefore, you are getting a point in the front view. Similarly, C, you have C dash only one point. So, since this is the side and this is the corner. But since he says its corner is resting on HP, so you rotate this first position pentagonal lamina such that the C is resting on XY line, and you rotate it by an angle of 30 degree with respect to HP. So what is the position of the lamina with respect to both HP and VP? The lamina is inclined to HP and perpendicular to VP. Since the surface is perpendicular to VP, therefore you are getting a line in the front view. So to this I need to write the top view. How to write that? Draw a vertical projector from A to the HP, similarly from E to the HP, similarly from B to the HP. Then similarly from B and D, you draw a vertical projector to touch on HP. Then of course C is obviously on the horizontal plane. Therefore, you mark these points, small a, b, c, d, e and f. Once you do that, then you complete this pentagon. So, since what is the position of the second position front view and top view? The surface is perpendicular to VP. Since the surface is perpendicular to VP, therefore you are getting a line in the front view. And the inclination will be C with respect to HP is in VP. Then the surface is perpendicular to VP and inclined to HP. Since it is perpendicular to VP, you are getting a line in the front view. So this is how you will be able to analyze the second position, front view and top view in 3 dimensions. Now how to write this? So since its corner is resting on HP, take any convenient distance from this point to, from first position C dash to the second position C dash, and you mark that point on the XY line and you mark that point as C dash because the corner is resting on HP. So this end is a side and this end is a corner. Since its corner is resting on HP, so you take any convenient distance from this point C dash on the XY line and you mark that point. Then go and mark that point and write it as C dash. With C dash as center, you measure an angle with respect to the horizontal for 30 degrees. By using the protractor, you measure with C dash as center with respect to the XY line, you measure in clockwise direction for 30 degrees and then draw an inclined line. Then I need to transfer these points. Which take the first position front view and you mark that distance from C dash to A dash. Correspondingly from C dash you draw a line. You draw an arc such that you will go to cut this point cut here. And you mark this point as A dash is in bracket and M dash is in bracket. Similarly with C dash as center, from the first position front view, you measure the distance of B dash to C dash. With C dash as center, cut an arc on this inclined line. You mark that point as B dash and D dash. Then join A dash to C dash with a dot line. Now to this I need to write the top view. How to write the top view? Draw a vertical projector from A dash, E dash and M dash to the top view. And draw a horizontal projector from A and draw a vertical horizontal projector from C and M and draw a horizontal projector from E to this perpendicular line. And you mark that point as A, M, E. Then draw a vertical projector from B dash and D dash and draw a horizontal projector from B to the second position top view. Similarly from D also you draw a horizontal projector such that these two projector lines will going to intersect for a projector line drawn from B dash D dash, and you mark these 2 points as B and D. Then you draw a vertical projector from C dash and draw a horizontal projector from C. Both these 2 points will go, both these 2 lines will going to intersect at the point C, and you mark that point as C and you mark this point as M. Then join A to B, B to C, C to D, D to E, E to M with a dot line. So this is how you will be able to write the second position front view and as well as the top view. As we rotate the position, as you see here, as you rotate the position here, that is even represented by gray line, gray shadow. So that is the actual position of the lamina. But the other things what we have shown here in vertical plane and also in the horizontal plane, these two are the images. Once you do that, then he says the perpendicular bisector passing through the edge on passing through the corner on which the lamina is appears to be inclined. Since he says it is appears to be inclined, so here as the surface is become inclined to HP, then the perpendicular bisector is on that surface. You can see that CM is on that surface. As we rotate the surface with respect to HP, similarly CM, which is the perpendicular bisector, is also getting rotated. So when you project this point here, what happens? M will be in apparent length. CM will be in apparent length. So, but what he has given the apparent inclination, because you can see it appears to be inclined. It is not actually inclined to that angle, but it is inclined at some other angle. But it appears to be inclined to a angle of 30 degrees. So since this perpendicular bisector passing through the corner is inclined to HP, so obviously in HP you will going to get the apparent length. Since the inclination given in the drawing is also apparent inclination, and the length what we have in the second position top view is also apparent length, therefore you rewrite the same second position top view by rotating at an angle of 30 degree with respect to VP. So that is the position what we have shown in the grey color lines. And then as you look from the top view, you project all these 5 points to the HP and then complete the pentagon such that it is appears to be inclined to VP at 30 degrees. Then to this, when you write the front view, you can project all these points, that is E dash and this is A dash. Similarly from B dash and also from D dash, and from C dash also you draw a horizontal projector. You mark these points as A dash, B dash, C dash, D dash, E dash. Okay. Then join A dash to B dash to C dash to D dash to E dash, and E dash to A dash with a dot line. And this is how you will be able to analyze the pentagonal lamina by using the 3 dimension. Now how to write this sketch here? As we rotate the surface with respect to HP, since the pentagon is on, since the perpendicular bisector is on that particular surface, therefore C dash M dash is also become to HP, inclined to HP. As we rotate the surface with respect to HP by 30 degrees, then the corresponding perpendicular bisector passing through the point C dash will also be inclined. As it becomes inclined, then what happens? You will not be able to get the true length here in the top view. So, you need to, will not be able to, then what is the inclination given? The inclination given is the apparent inclination in the problem. What is the length of this CM? The length of this CM is apparent length. So, from the projections of lines, we know that on apparent inclination, you should get only apparent length. So, I need to rewrite the same second position top view by rotating at an angle of 30 degrees with respect to VP. So, consider any point with reference to the horizontal. You measure an angle of 30 degrees and then join between then we have 30 degrees. Then you measure the distance from C to M from the second position top view with C as center, cut an arc on that 30 degree line. You mark that point as M. Similarly, you measure the distance from C to this point and transfer it from this point to on this CM line. And then through this point, you draw a perpendicular by 90 degrees with respect to CM. Then you measure the distance from this point to D and also from this point to B. Both will have equal distances and transfer it from this point onto this side and also from this point onto this side. So you mark these 2 points as B and D. Similarly, you measure the distance from C to M with C as center, cut an arc on this 30 degree line. Then through M, you draw a perpendicular to this CM. And then you measure the distance from M to A and also from M to E. Both will have the equal distances by using the compass. Similarly, with M as center, cut an arc on this side and also an arc on this side. You mark these 2 points as A and E. So, since we have projected or rewrote the second position top view here by rotating at an angle of 30 degree with respect to VP. It is appears to be inclined, therefore you will going to get the apparent inclination, and since the second position top view you have the length which is apparent length. So from the projections of lines on the apparent inclination line you have to transfer the apparent length. So since the apparent length here is CM, with C as center, cut an arc on this 30 degree line and you mark that point as M. Then through M with respect to CM, you measure an angle of 90 degree with respect to CM by using the protractor. Through M, by using the compass, you measure the distance from M to A and M to E. Both will have equal distances, and then by using the compass with M as center, cut for this 12.5 mm on this side and also 12.5 mm on this side. Then you mark these 2 points as E and E. Then similarly with C as center, by using the compass, you measure the distance from C to this point, that is on CM. With C as center, cut an arc on this. Then through this point with respect to the CM, you measure an angle of 90 degrees and then draw an inclined line passing through this point to the bottom side. Then you measure the distance from this point to B and also from this point to D. Both will have equal distances. Therefore, from this point, you cut an arc on this side and also cut an arc on this side. So, as we rotate it in counterclockwise direction, you will going to get A here, B here, C here, D here, E here and F. Then join A to B, B to C, C to D, D to E, E to A with a dotted line. So this is how you will be able to write the third position top view. Then by using a horizontal line with respect to A dash, by drawing a line horizontally to the third position front view. Then from you draw a line from the perpendicular bisector of this point AM. So you draw a vertical projector from A till here, and similarly from A also you measure you draw a vertical projector to a horizontal projector drawn from A dash and A dash in the from the second position top view, front view. Then you mark these 2 points as A dash and D dash and draw a horizontal projector from B dash and D dash. Then from D you draw a vertical projector to B dash D dash. Similarly from B also you draw a vertical projector such that it will going to cut this horizontal projector drawn from B dash and D dash. You mark that point as D dash and B dash. And then similarly you draw a horizontal projector from C dash from the second position front view, and then from C you draw a vertical projector to the XY line. You mark this point here. You mark this point as C dash. Then join A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, and E dash to A dash with a dotted line. So this is how you will be able to analyze the problem in 3D and also solve it by manually. How do I know that my problem is right? Even in the final position, you can see that the corner is resting on HP. Then the perpendicular bisector passing through the corner on which the lamina rests appears to be inclined to VP at 30 degrees. Since the apparent inclination is given, therefore you will going to get the apparent length in the second position top view. Then here the surface is inclined to HP at 30 degrees and corner is resting on HP, and this is a pentagon of 25 mm side. So this is how you will be able to analyze and solve the problem in this manual sketchbook, and also you can verify it by telling that verifying that whether the problem is right or wrong. So here even in the final position you can see that the corner is resting on HP, the perpendicular bisector appears to be inclined to VP, and the surface is inclined at 30 degrees to HP, and it is a pentagon of 25 mm side. So this is how you will be able to analyze the problem in 3 dimensions and also solve it manually by using the sketchbook. Thank you.